Hi students, I am your Nagini ma'am, chemistry mentor. In today's session, I am going to teach you excellent tricks to solve solubility product and solubility questions easily, students. This is the topic Ionic equilibrium, 11th class chemistry students here. This topic is important for NEET and JEE also. Clear? Right. Solubility. What is the solubility, students? The number of moles of solute dissolved in a given volume of the solvent. Number of moles of solute dissolved in a given volume of the solvent is nothing but solubility. Understanding? So S is equals to number of moles N. So given volume of the solvent, volume is V. What is the unit number of moles? Mole. This is volume, liter, mole per liter. Understanding? So here this solubility is meant for insoluble salt, students. Okay, now for strong electrolytes, if I take strong electrolytes, they undergo complete ionization in water. Okay, now completely dissociate into ions. 100% dissociation takes place in water. But coming to here, insoluble salts, sparingly soluble salts, weak electrolytes, they are not undergoing 100% dissociation in water. Are you following? Okay, now they are less soluble in water, weak electrolytes. So that's why for weak electrolytes we can calculate the solubility. For strong electrolytes you don't need to calculate the solubility because 100% solubility will be there. For weak electrolytes they will not undergo complete ionization. So that's why we can calculate the solubility for insoluble salts. Are you following? For weak electrolytes. Clear? So that's the solubility is meant for insoluble salts. Understanding? Insoluble salts. How much salt is soluble in water? How many moles of salt is soluble in the given solvent? Understanding? We can calculate only for the insoluble salt solubility. So for example, I am taking silver chloride, AgCl. AgCl. It is a weak electrolyte. It is a sparingly soluble salt. Less soluble in water. Right. It dissociates into Ag plus and Cl minus. Its solubility yes. Its solubility yes. I am taking. What is the equilibrium constant? Product of the product's concentration by reactant concentration. Are you following this? Already we know this formula. Equilibrium constant. Products concentrations by reactant concentration. Yes. Ag plus and concentration here I am taking as solubility yes. This solubility yes. Its solubility yes I am taking. Now here see students, here solubility yes. Instead of Ag plus I am taking as yes. Okay, yes, Cl minus solubility how much? Yes, by AgCl. AgCl I am taking because AgCl is a less sparingly, it is a less soluble salt. Understanding? It is a weak electrolyte. So that's why its concentration I am considering as constant. Are you following? So AgCl concentration I am considering as constant, students. So that's why Kc into this is constant, Kc into AgCl, it is a constant, is equals to S into S. Are you following? Kc into AgCl is equals to S into S. Then Kc into AgCl, this is completely constant. Then that's why here instead of this I am taking Ksp. This is the solubility product constant. Are you following? Solubility product constant. It is equals to S square. Then Ksp is equal to S square means S is equals to what, students? Square root of Ksp. This is the relation between solubility product and solubility, students, for this salt. Are you following? For this salt, this is the relation, students, Ag plus and Cl minus. So this is the method. Like this we have to calculate the relation between solubility product and solubility for given salt, for the given salt. But this is the time taking method. Are you following? It is the time taking method. You don't need to calculate, you don't need to do this much calculation. Understanding? So by seeing the compound, what electrolyte given, okay now, so for that electrolyte directly you can calculate the relation between solubility and solubility product constant, student. This much you don't need to do. Are you following? So now I will discuss the trick number 1. Now see here, what is the trick? See here, trick number 1. See here, students, what is the trick? Trick number 1. So for the given salt, how to calculate the relation solubility product constant and solubility? So here there is a formula, students. Here K sol Sp, solubility product constant, is equals to formula A power A into B power B into S to the power of A plus B. Nana. Okay, just you remember this trick, students. You can calculate any salt relation, students. That means any salt solubility product constant and solubility relation you can easily calculate by using this formula. This one, see how to apply this one. Suppose this salt only I am taking silver chloride. See here students, silver chloride I am taking. Silver, A is nothing but number of atoms students, understanding? B also number of atoms. This is cation, this is anion. Are you already, we know that in the given salt always the first place cation will be there, next place anion will be there. So how many atoms are there? Silver atoms how many are there? That is A. Chlorine atoms how many are there? That is indicates B. Are you following? Now silver how many atoms are there? 1. Chlorine how many atoms are there? 1. So A is equals to how much students? 1. B is equals to how much students? 1. A equals to 1, B equals to 1. Okay, then you just these two values here substitute in this formula. For AgCl salt, solubility product constant is equals to A power A, 1 power 1, B power B, 1 power 1, S to the power of A plus B, 1 plus 1. How much students? 1 into 1, 1, S to the power of 2, S square. KSP is equal to S square. That only we calculated here. KSP is equals to S square. Are you following? So just use this trick, you can easily calculate for any salt this relation easily. Okay, this one. Now take one more salt students, for example barium sulfate I am taking. Second example. Okay, now see here how to calculate for barium sulfate relation between solubility product constant and solubility. See here, barium sulfate. What is the solubility product constant? A power A into B power B into S to the power of A plus B. Now tell me barium how many atoms are there? 1 atom is there. Barium 1 atom only na? So barium 1 atom. Sulfate SO4 groups how many are there? 1 group is there. Are you following? So just to substitute here, A is equals to 1, B is equals to 1. Then solubility product constant is equals to 1 power 1 into 1 power 1 into S to the power of 1 plus 1. You will get same value. Clear? So same value you will get. Now take one more salt. Okay, this is barium sulfate. Now I will take different salt. See here. See students, different salt I am taking now. Different salt. Right. Now take here different salt, lead iodide, PbI2. So what is the solubility product constant relation? Tell me formula fast. A power A into B power B into S to the power of A plus B. This is the trick. Okay, how to apply this one for this salt? How to calculate relation KSP and solubility? Lead, how many atoms are there? Lead 1 atom is there. Iodine 2 atoms are there. Lead 1 atom, iodine 2 atoms. Then A is equals to how much? 1. B is equals to 2. A equals to 1, B equals to 2. That much only. Substitute here in this formula. Solubility product constant is equal to A power A, 1 power 1, B power B, 2 square, S to the power of 1 plus 2. Then 4 into S to the power of 1 plus 2 means how much students? S to the power of 3. So KSP is equals to 4 into S cube over. Understanding? So this is the relation for this salt. Are you following? This one like this we have to find. Now take one more example students, PbI2 over. Next one, calcium phosphate, Ca3PO4 twice. For example, this salt Ca3PO4 twice. What is the relation between solubility product constant and solubility? KSP is equals to, tell me, A power A into B power B into S to the power of A plus B. Now tell me A is equal to how much calciums? How many are there? Calcium how many are there? 3 are there. PO4 groups how many are there? 2 are there. So A is equals to how much students? A is equals to 3. B is equals to 2. Clear? B is equals to 2. Substitute in this formula. KSP is equals to 3 power A, 3 power 3, B power B, 2 square into S to the power of A plus B, that is 2 plus 3. Clear? 3 plus 2. How much students? 3 cube means how much? 27 into 2 square 4, S to the power of 5. Then you will get 108 into S to the power of 5. This is the solubility product constant relation. Clear? This is the calcium phosphate students. Clear? Now take one more example. See, calcium fluoride, CaF2. Tell me fast. A is equals to 1, B is equals to 2. Then what is the formula students? KSP is equals to 1 power 1 into 2 square into S to the power of 1 plus 2. Then 4 into S to the power of 3, 4S cube. This is the relation. Clear? Understanding? So like this we can easily find out students. Now in this trick number 1, how the questions will be there? See here. So in questions runner, solubility they will give KSP value. So solubility they will give KSP value we should find. Or KSP value they will give solubility we should find. This is the first model question. Understanding? So based on the trick number 1. Okay na? So what questions will be there? Now we will see students. See students, question number 1, the solubility of CaF2 is 2 into 10 power minus 4 mole per liter. Solubility product we have to find it. So solubility given, solubility product we have to find. What is the salt given students? What is the salt given? See here, CaF2 given salt. CaF2, okay. CaF2, first you calculate CaF2. What is the relation between solubility and solubility product constant? Relation calculate what by using trick number 1. CaF2 kada, calcium, A is equals to 1, B is equals to 2, correct? A equal to 1, B equals to 2. Now what is the solubility product constant? A power A, 1 power 1 into B square, B power B, 2 square. Are you following? Into S to the power of 1 plus 2, A plus B. Then here how much you will get? 4S cube. So KSP is equals to how much students? 4S cube. Here what given? Solubility given. Solubility product is asking. So solubility value given, KSP is asking question. Right. Substitute in this formula, KSP is equal to 4 into S cube. Solubility how much given? 2 into 10 to the power of minus 4 whole cube given. Then what is the solubility product constant students? KSP is equals to here 4 into 2 cube. 2 cube is how much students? 8 into 10 power minus 12. Now tell me 4 8s are how much? 4 8s are 32 into 10 power minus 12. This one we can write based on this option. See here, this one it is matching. So 3.2 into 10 power minus 11. So this is the correct option. Clear? Clear up? Understanding? So like this we have to find. First use, that means first give what is the salt given. First you calculate by using trick number 1, formula calculate. What is the relation between KSP and S? Then what asked? Solubility given, solubility product we have to calculate. Like this you have to calculate. This is the correct option. Now see second question. If S represents the solubility of Hg to Cl2, the expression for the solubility product is asking. So what given? Hg to Cl2 given. Calculate Hg to Cl2 by using trick number 1. What is A is equals to 2, B is equals to 2. Then what is the formula student? Solubility product constant, KSP is equals to 2 square into 2 square, S to the power of 2 plus 2, 4 into S to the power of 4. 4 4s are how much students? 4 4s are 16, S to the power of 4. So 16 S to the power of 4, answer option D is the correct answer. Clear? Understanding? Clear? 16 S to the power of 4. This is the correct option. Only relation is asking. Now see another question. If S represents solubility of Ca3PO4 twice, the expression of S in terms of KSP is asking. So calcium phosphate is asking here. Ca3PO4 twice. How much A? 3. B how much? 2. Use trick number 1. What is KSP students? 3 cube. 3 cube, next 2 square. Are you following? A power A, B power B into S to the power of A plus B, 3 plus 2. Then 3 cube 27 into 4, S to the power of 5, 108 S to the power of 5. Clear? This is KSP. So KSP is equals to 108 S to the power of 5. S to the power of 5 is equals to KSP by 108. Then S is equal to what we can write? 5th root of KSP by 108. This is the correct option. KSP by 108. What is the correct answer? Option A is the correct answer. Clear? Option A is the correct answer. Clear students? Like this we have to find. Now see another problem. KSP of silver chloride is 10 power minus 10. So KSP value given, solubility we should find. Okay. Now first for the given salt you have to calculate by using trick number 1 formula. AgCl solubility product constant is equals to A is equals to 1, B is equals to 1. A power A, 1 power 1, B power B into S to the power of A plus B. Then here S square solubility product constant. Now KSP value given, substitute here 10 power minus 10 is equals to S square solubility S square. So S value we have to calculate. S is equal to square root of 10 power minus 10. Then S is equal to square root of 10 power minus 10 whole to the power of 1 by 2. You will get 10 power minus 5 mole per liter. Clear? So that means what is its solubility? 10 power minus 5 moles of silver chloride salt is dissolved in 1 liter of water. Are you clear? So this is about the solubility. So solubility given, so solubility product constant we have to find. KSP given, solubility we should calculate. Understanding? So like this we have to calculate students. This is a trick number 1 model questions. Okay. Now trick number 2. What is the trick number 2 students? See here. Trick number 2. What is the trick number 2? See here. So here KSP values, okay na, for two electrolytes, KSP values nana for two salts nana they will give, okay, X and Y. Suppose KSP values they given, you have to calculate solubility. Till now one solubility given, KSP calculated, KSP given, solubility calculated, or relation asked, calculated. Now here what asking, two salts they will give, KSP values they will give. For two salts KSP values they will give, or either X or X and Y. Okay, now you have to calculate the solubilities. This is the second model problems based on the solubility product. Understanding trick number 2. Now see here, based on this trick number 2, what are the questions you will get? See students, based on the trick number 2. So here silver chloride, calcium fluoride, two electrolytes, KSP values given. KSP values given students. Okay, two salts, KSP values given. We have to calculate the solubility. Here question is which salt has more solubility in water is asking. Which has more solubility in water. So this is more soluble, this is more soluble in water, they are asking question. Understanding? This is the trick number 2 model question. Okay. Now how to calculate? First here solubility product constant given. You calculate solubility, this salt solubility, this also solubility calculate. Okay, then in that solubility which is more value, that is more soluble in water, that much only. See here, first take silver chloride solubility calculate. What is the formula students? KSP is equals to silver chloride, A is equals to 1, by using trick number 1, A is equal to 1, B is equals to 1. Then KSP is equals to, what is the relation? 1 power 1 into 1 power 1 into S to the power of 1 plus 1. Use that formula, trick number 1. Okay, then KSP is equals to S square, S to the power of 1 plus 1, correct? S square we got. That means KSP value already given 10 power minus 10. Then what is S square students? 10 power minus 10. Then S is equals to square root of 10 power minus 10. You will get 10 power minus 5 mole per liter. This is about AgCl. Okay, clear? 10 power minus 5. This is AgCl solubility completed. Now we will calculate calcium fluoride. See here calcium fluoride, CaF2. What is A students? A is equals to 1, B is equals to 2. Then solubility product constant is equals to 1 power 1, 2 square, S to the power of 1 plus 2. Then you will get 4S cube relation. Right. Now KSP value how much given? 4 into 10 to the power of minus 12 given into 4S cube. Then S cube is equals to how much students? 4 cancel, 10 power minus 12. Then you can get S value. S is equals to 10 power minus 12 whole to the power of 1 by 3. Correct? Understanding? Then you will get 10 power minus 12 whole to the power of 1 by 3. You will get answer 10 power minus 4. Understanding? 10 power minus 4 mole per liter. Clear? 10 power minus 4 mole per liter. Now once you observe students here, question is which salt has more solubility in water asking. Which has more solubility in water? This is silver chloride solubility. This is calcium fluoride solubility. Okay. Solubility is calculated. This is 10 power minus 5 mole of silver chloride dissolved in 1 liter of water. This is 10 power minus 4 mole of calcium fluoride is dissolved in 1 liter of water. That's what we can say students, which has more solubility. In negative values, which is the small value, that is the more value. Understanding? So it is more soluble in water. Correct? In negative value which is small, that is more value. Okay. So this is the more value. So this is more soluble in water. Clear? More soluble in water. Clear students? Understanding? So CaF2 is more soluble in water. Clear? This is the second model question, second trick number 2. That means two salts KSP values they will give. You have to calculate solubilities. Understanding? So separate the AgCl relation calculate, CaF2 relation calculate solubilities. Which is the more value, that is more soluble in water. Clear? Clear? Now trick number 3. Now see students, trick number 3. Trick number 3. Okay, this is based on the common ion effect. Trick number 3. Now see students, for example, okay, silver chloride I am taking. This is the silver chloride solution. Okay, silver chloride. Here also I am taking. See, this is also silver chloride. Now when we are adding common ion, Ag plus. And that means what we are adding? Silver nitrate solution is adding. Then here silver nitrate, silver chloride. What is the common ion student? Silver. Kada? So silver. Now here also when we are adding KCl solution, here what is the common ion, student? Cl minus, correct? Now when we are adding common ion, understand this is silver chloride, this is the weak electrolyte. When we are adding strong electrolyte, silver nitrate, to the weak electrolytic solution, there is a common ion. Ag plus ion concentration increases, correct or not? According to Le-Chatelier's equilibrium shift in the direction backward. Okay, na, backward direction. That means the silver ions, Ag plus ions, backward direction takes place. Ag plus ions, okay, reacts with the chloride, produces undissociated silver chloride according to Le-Chatelier's. Okay, so you have to remember in this trick, Nana, just whenever strong electrolyte is added to the weak electrolyte solution, the weak electrolyte solubility decreases. Understanding? Here just you remember, students, common ion effect. Due to the common ion effect, understanding, due to the common ion effect, the solubility of salt decreases. Clear? Due to the common ion effect, okay, solubility of salt decreases, students. Okay, here see AgCl weak electrolyte, whenever Ag plus ion, common ion is added, then its solubility decreases. Whenever KCl is added to the weak electrolyte AgCl solution, common ion is there, chloride. So common ion is added, then what happens? Solubility of AgCl decreases. Just you have to remember this point, students. This is the trick number 3. This point is very important. Clear? So due to the common ion effect, the solubility of salt decreases. Understanding? Now see, based on this trick number 3, we will discuss one model question, students. See, students, solubility product constant of AgCl. Understanding, based on the trick number 3, students, question. Okay, see here, solubility product constant of AgCl is 10 power minus 10. No? So Ksp value given. Solubility in water we should find, and the same salt solubility in 0.1 molar silver nitrate also we have to calculate. Understanding? So that means in water, what is its solubility? Whenever silver nitrate is added to silver chloride, and that means silver chloride solubility in 0.1 molar silver nitrate. Here Ag is there, common ion is there. So that's why compulsory this solubility, what is happening? Okay, na? Because of this silver nitrate, silver chloride solubility should be decreased. Understanding? So when compared to this solubility in water, this value we should get less value. Understanding? Because in water its solubility you will get some value. Okay, suppose x value, suppose this solubility value we got 10 power 4 like that. Then silver nitrate is added, then what happened? Its solubility should decrease. Na? That means this is 10 power 4 means this value compulsory it should be less than 10 power 4. Okay, na? Because of common ion effect, solubility of salt decreases. Clear? Okay, solubility should decrease. In water its solubility is more, but whenever common ion is added, its solubility should be decreased when compared to water. Understanding? Now we will see, students. Okay, first we will calculate the solubility in water. Okay, so silver chloride takes salt. Okay, silver chloride, A is equals to 1, B is equals to 1. What is Ksp, students? Ksp is equals to 1 power 1 into, based on trick number 1, 1 power 1 into s to the power of 1 plus 1. What is the formula? S square. Solubility product constant S square. Okay, Ksp value already given. So then what is S, students? Square root of 10 power minus 10. S is equals to 10 power minus 5 mole per liter. This is the solubility 10 power minus 5 S square. So this is the solubility of AgCl in water. Clear? This is the solubility of AgCl in water. 10 power minus 5 moles of AgCl dissolved in 1 liter of water. Clear? Now I am going to calculate silver nitrate. In silver nitrate, what is its solubility? Silver common ion is there. That's why compulsory its solubility should decrease when compared to water. Now we will see, we will check it. See here, AgCl. See here, AgCl. Whenever this, see AgCl is AgCl. I am taking here calculation part. See here, AgCl, it dissociates into Ag plus and Cl minus ions. Clear? Ag plus and Cl minus ions. Okay, Cl minus ions. Now silver nitrate is added. What is its solubility, students? Yes, so its solubility, yes. Okay, in water. Now whenever 0.1 molar silver nitrate is added, now silver nitrate is added. So silver nitrate dissociates into Ag plus and NO3 minus. Correct? Ag plus and NO3 minus. What is its solubility, students? How much given here? 0.1. This solubility 0.1 molar given. 0.1. So whenever this silver nitrate is added to AgCl, okay, AgCl, what happened? Ag plus ion, common ion, its concentration increases in the solution. Are you following? This is, suppose this is silver nitrates, this is the silver chloride. When we are adding silver nitrate, what happened? Ag. So what happened? In the solution, Ag plus ions concentration increases. Correct? Here Ag, here Ag. This concentration increases kada. So Ag plus ion concentration, it is yes. Whenever silver nitrate is added, its concentration, its solubility is 0.1 given. So S plus 0.1 increased. Are you following? Ag plus ion concentration is increased by S plus 0.1. But Ag plus ions, here its solubility S, here its solubility is 0.1. When compared to 0.1, S solubility, here Ag plus ion solubility is yes. Yes, sir. Now wait. For AgCl, for this AgCl, just you calculate KSP value, students. What is the solubility product constant? Products concentration kada. Ag plus ion concentration into Cl minus ion concentration. How much Ag plus value? Solubility S plus 0.1. Cl minus is S. Okay. Just these concentrations we are taking here. Right? Now S plus 0.1 into S we are taking, but this S I am neglecting, students. It is negligible because when compared to silver, because it is a strong electrolyte, it is a weak electrolyte. That's why in the solution Ag plus ions which are obtained from the weak electrolyte, this value is less. This value is less when compared to Ag plus ion. So this is less, students. Are you following? S value is less. That means it is a weak electrolyte. Very less number of Ag plus ions will be there in the solution. But Ag plus ions which are obtained from the strong electrolyte, these ions are more. That's why this solubility is I am taking as very less. It is negligible. So that's a yes when compared with 0.1. Yes, I am neglecting. So then 0.1 into yes. How much, students? KSP is equals to 0.1 into S. But KSP value already given 10 power minus 10 kada. 10 power minus 10 is equals to 0.1 into S. Then S is equals to how much, students? 10 power minus 1 by 0.1. S is equals to 10 power minus 9 mole per liter. This is arrow silver nitrate. Okay. This is the silver nitrate, students. Are you following? Silver nitrate. Now see, solubility of AgCl in water 10 power minus 5. Solubility of silver nitrate, solubility of AgCl in silver nitrate is 10 power minus 9. I told you this in silver nitrate compulsory AgCl solubility should decrease. It is smaller value, na? See here 10 power minus 5, 10 power minus 9. It is negative value, it is more. When compared to this one is more, negative value. So negative is more means that is the less value. That means it is less soluble. Understand, its solubility is less. 10 power minus 9 mole only dissolved in silver nitrate here. Okay na? Dissolved in silver nitrate. But in this water, 10 power minus 5 moles dissolved in water. In AgCl salt. Clear? Understanding? If suppose here we got more value, okay, more value, then here yes we should not neglect, students. Understanding? Here we got okay, less value when compared to this. If suppose by neglecting this one, if we got here more value when compared to this, then compulsory you should not neglect this one. here we neglected, but based on this value, okay na, we have to neglect we should not neglect that one. It is depends on this value. Are you following? This is the trick number 3, students. Okay, common ion effect. I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, students. Thank you, thank you, thank you very much, students. Please subscribe, Nana, please subscribe. Thank you.